I am an avatar organized by Dr. Alemi. This presentation is on hierarchical regression models, where gradually one adds to the model complexity. Hierarchical regression is a technique used to assess the incremental value of adding one or more sets of variables to a regression model. Start by using a simple linear regression, where you predict an outcome variable y using sum of n different predictor variables. In this regression, each independent variable is independent from others. This model is also called a main effect model. Here we start with a prediction made from the mean of distribution of y. Next, we see if adding the variable x1 will improve the predictions. Next, we examine if adding x2 will also improve the prediction. In this next iteration, we examine if the interaction of x1 and x2 improves the prediction. The point is that we continually add more complexity in our model to see if it makes a difference. The R-squared is used to measure the goodness of fit between the equation and the data at every step. It reports the strength of association between the outcome variable denoted by y and the independent variables. The value of R-square can be anywhere from 0 to 1, where 0 highlights no association at all. An R-squared of 1 indicates that the independent variables perfectly predict the dependent variable, an unusual value that typically occurs when the model is overspecified. As the number of variables increase, the model fits the data more closely. This does not mean the model is more accurate. The adjusted R-square corrects the R-square value by the degrees of freedom available. The statistic R-square is sensitive to the size of the data. As the size of data increases, there is more variability, and a smaller percent of variability could be explained. An R-square of 25% may be low in a small but reasonable in a massive database. In small data, there is less variability to begin with. The steps are to first run the base regression model. Usually you include control variables or main effects into this base model. In step 2, add additional variables into the regression. You need to have a theoretical reasons for adding these variables. Don't just go fishing for maximizing the percent of variation explained. Next, assess significance of changes in adjusted R-square. If additional variables are informative, they must add significant amount to the R-square value. You can repeat these steps to add in other variables of interest. Hierarchical analysis is often used to check on the existence of interaction effects. In regression, the interaction between two variables is defined as the product of the two variables. Here we see pairwise, triple-way, and four-way interactions, each time calculated as product of a set of variables. To understand why we measure interaction as a product of two variables, consider two binary variables. The product of two binary variables is another binary variable, which is always 0 except when both variables are 1. This is a very particular way of measuring interactions. The product of a binary and a continuous variable will be 0 when the binary variable is 0, and equal to the continuous variable when the binary variable is 1. The product of variables is a particular way of measuring interactions. Let us look at an example of hierarchical models. This study examined the role of social and medical determinants of suicide. We tried 40 variables each depicting one of the social determinants of illness. Nearly 60% of variations in suicide was explained by social determinants of illness. Things like homelessness, elevated risk of suicide. This made sense, but this is not the total story. We then tried 10,445 binary variables depicting the medical history of the patients. These explained more of the variation in suicides. Things like psychosis increased the risk of suicide. This too made sense, but is not the entire story. We finally tried both the social and medical determinants of suicide together in the same regression. The effect of the combined set of variables was surprising. Social variables did not improve the percent of variation explained by medical history. This study showed the value of hierarchical modeling in providing insights. To construct accurate models, do so gradually by adding additional variables and seeing if these variables or their interactions are informative. Thank you for listening to me. This ends my presentation.